So starting with the warm-ups though, we're gonna do what we learned yesterday. So write this off to the side. 3x plus 4y equals -8. So this is a review problem from yesterday. And I have a problem that's in standard form and I want to convert it to slope intercept. Please stop. He probably deserved it, but please stop. I was just kidding. It was supposed to be funny. Okay. Now, step one, undo the x thing first. Okay. Step one, undo the x thing first. Step two, put the x in front. Step three, divide if you have to get y by itself. Okay, and I'm going to rewrite this. Y equals -3/4 x minus 2. Okay, so minus 2 means that you go down 2 for b. So start by graphing -2. And then the slope is -3/4. So go down 3, right 4. And if I can, on the graph, I'll also backtrack up 3, back 4. Apparently, my ruler is gone. I don't know. Truth be told, even if I found it, I couldn't pick it up. Maybe. I think it's mad at me because the joke in my Math 3 PowerPoint today was about rulers. It was about the ruler being the ruler of the junk drawer. Appreciate you. Okay. Any questions about number 2? How are we doing with what we learned yesterday? Okay, good. Okay, now move down to number 4. This is the old stuff. So x1, y1, x2, y2. Shh. M equals y2 minus y1 over x2 minus x1. You have to be really careful with the negatives in this one. I know. Confusing. Okay, so this becomes -3 plus 1, which is -2. And this becomes -2 plus 4, which is +2, which is -1. -1. Okay, and then you pick either one for your x1. I'm just going to pick the first one. So x is -4, y is -1. Y equals mx plus b. -1 equals -1 times -4 plus b. Oh, I love it when they're all whole numbers. Oh, good. -1 equals 4 plus b. -5 equals b. Okay, now some of you might have just written -x minus 5. That's the same thing as this, just a little bit more sophisticated than mine, but otherwise the same. You guys have any questions about Number 2 or number 4? All good? Okay. Don't put this away yet. We're going to use part of it for today's digital escape. Why do we have two digital escapes in a row? I don't know. Just because it worked out that way. Just it just didn't work out that way. So weird. So weird. I have stuff over here, but damn. Yeah, I definitely have piles of stuff. I got scented flare pens in my stocking. Yeah, they smell good, except for this blue one kind of smells like perfume, and I don't like that one. I also got a daily rip-off Squishmallow calendar in my stocking. Like, see, like every day there's another Squishmallow, and then it says today's date, and then this is today's Squishmallow. And Miss Rice got me a book of 2,000 Squishmallow stickers. I know, I know. I had a great Christmas. Christmas is good. And I got Cheez-Its, which you might not think are a big deal, but I try not to eat carbs, so. Okay, so 13A. This is what we learned yesterday. What we just did in the first warm-up problem. I want you to do this one yourself. Solve it from standard form, slope, intercept. You can do it. Okay, when you're ready, check your answer. The answer is y equals negative 4/3 x plus 4. Any questions? Yes.
I just did this.
What is it?
I did 1 and 1/3.
So slopes are supposed to be reduced fractions because if you think about it, this is 4 boxes and 3 boxes. And 1 1/3 would be hard to graph. Do you know what I mean? So try to keep your slopes in reduced fractions. Okay, now B. B is a review problem from first semester, but it's super important, so I thought we should go over it. On this side, we're going to distribute, but on this side, box. Excellent. Okay. I'm gonna make my box down here so that I have room to work underneath. Okay, so on this side, when I distribute, x times 2x is 2x squared. And x times -1 is -1x. I just wrote -x. And then this side is going to be the stuff I get from the box, which is 2x squared. Combine those, 5x minus 12. Okay, what did I promise you was going to happen all through math 1?
We're not doing
Squareds.
squares.
We're not doing squareds. So squareds will cancel this whole year. Next year, no, but this year, yes. Minus 5x. Okay, now, see, this one is definitely important for 2 reasons. First, I want to make sure that you don't do 2 minus 3. That is not proper order of operations. You need to distribute, and you need to be very careful and distribute -3, not regular 3. So we have 2 minus 6x plus 3. Does anyone see anything weird? Yes. Okay. So that's the other thing I wanted to talk about. When they're the same on both sides, is it no solution or infinite solutions? Infinite. Great. Okay. I don't know if this is good news or bad news, but none of that was the spicy stuff I was talking about. Okay. Okay. This is old stuff. So you had a review from yesterday. That other stuff was from first semester. Now, why did we do it? And the reason we did it is because we want to focus on undoing today. So today's is spicy, as I said, but if we can focus on how we did these, it will help us a lot with the spicy ones. Yeah. Yeah. Okay. So this is not the time to tune me out. Think that first one you might know from physics. You guys do the triangle thing from physics? Yeah, that's what this is. Yeah, acceleration equals force over mass, yeah. The second one is the area of a triangle. Third one is work equals force times distance. Yeah. And then the last one is the Fahrenheit to Celsius conversion. The last one is the spikiest. If you have a calculator, it's not that bad. Okay. So for these problems, when we start them right now, I'm going to use a highlighter to help me. So I'm going to start with this one. And it says for M, what that means is M is the thing I need to get by itself. So I need to get M equals for my final answer. Okay, so I'm looking at this, and this is division. What operation undoes division? Multiplication. And when you multiply, you want to multiply both sides by the bottom. And whatever you do to one side, you have to do to the other. And then those two will cancel because M over M is 1. And you have M times A equals F. Okay, this operation is multiplication. How do I undo multiplication? Division. I want to get M by itself, so I need to get rid of the A. Okay, so the directions on these are, by the way, they're called literal equations. The directions on these is look at the parentheses here and get that letter by itself. So undo stuff till that letter is alone. Okay, now on this one, we have to undo stuff until H is alone. Okay, we're going to start with the half. What operation is a fraction? Division. How do we undo division? Multiplication. And you multiply by the bottom. Okay, now on this side, the half and 2 cancel. Okay, this operation is, yes, times, right? How do you undo times? Divide, right? And I want to get H alone, so I'm going to get rid of B. Okay, now C. This, I put this problem in here because I wanted to remind you that when two letters are right next to each other, that's times. So that's just the reason we did this. Yes, honey.
Divide by D.
Divide by D. Beautiful. So we want to get rid of the D, get F by itself. Okay, now D is spicy. We're going to do D in a couple of steps. Okay, we want to get this by itself. So we kind of have to undo. What was the last thing that happened? was plus 32, so we need to minus 32. This little circle, by the way, means degrees. Hey, Dylan, Celsius or Fahrenheit? Yeah, that's what I thought you were gonna say. Everywhere else in the world, except for us. Everywhere else in the world uses Celsius instead of Fahrenheit. We're special. Okay, anyway, so I got this. Do you guys all see this is dividing by 5? Okay, how do I undo dividing by 5? Multiplying by 5. Okay, now this is special. Notice I'm multiplying all of this by 5, so I need parentheses. Times 9, undo it, divide by 9. Yeah. Okay, so, yes, honey. Do you need to distribute is your question?
No, but
Oh,
would this formula actually be the same as the formula over here? Like, will these be the same or is it not, will it not be the same? Like, if you plug a number into this, will like,
okay. So if you plug a Celsius in here,
Mhm.
this would literally give you Fahrenheit. If you plug a Fahrenheit in here, it would give you back to the Celsius.
okay, I just wanted
They are real inverses of each other. Okay. Now, if you guys could find your next digital escape page in your packet. I'm gonna do the whole first puzzle with you. Because I think I should. So just separate it for now. Okay. All right, go ahead and write those are the 4 problems for the puzzle 1. Okay, and notice over here in the margin, I wrote for A. All 4 of these, the directions say to solve for A. So A is what we're looking to get by itself. Okay, these are not supposed to be super challenging because it's puzzle 1. So what operation is this? Subtraction. How do you undo subtraction? Addition. That's it. Like, don't overthink it. Once A is by itself, you're done. Okay, now the second puzzle has two steps. First, you look, we want A. Yeah. So first we subtract D. Division. Yep, beautiful. And you want to divide by B because you want A by itself. Okay, now we want A by itself. So what do we have to get rid of? D. And it's multiplying. Perfect. Okay, last one has division. How do you undo division? Multiplication. And what do you multiply by? The bottom, right? DC. And you can write all three of those next to each other. You can write time symbols. It doesn't matter. It doesn't matter the order of the letters either. Usually I like to leave it in alphabetical order because I'm a nerd. Okay, so if you want to help me figure out the code, A, E, D, C. Okay, can you guys all put in the code? Okay, I want you to start working on this. I'm definitely here to help you. I have puzzle 2 up if you need it. Do you guys all see that the colored one is the one that you're getting by itself? Okay, and it tells you what to solve for. Okay. Just give it a go. Yeah.
The puzzle one problem again?
A, E, D, C. Oh, can you see them?
Yeah.
Oh, of course. Yeah.